All right, time to make another connection. See, on this page, we're working on prime factorization. We're working on least common multiples, we're working on greatest common factors, etc. Well, the very bottom of the page has another problem, and if we think about it, we realize that this problem has a lot to do with prime factorization. A bell rings every 25 minutes. Another bell rings every 40 minutes. If the bells ring together at 6 a.m., at what time would they next ring together? Well, that's just this, isn't it? That's just saying if I go 12, 24, 36, 48, and then do multiples of 210, at what time will those meet again? Well, in this case, it's 420. So what I'm looking for down here is the least common multiple of 25 and 40. Oh, well, how did I find the least common multiple of this? I started out by finding the prime factorization of each one. Well, let's do that. The prime factorization of 25 is 5 and 5. Gosh, that was easy enough. These are both prime, so I'm done. The prime factorization of 40 is 5 and 8, but 8 is 2 times 4, but 4 is 2 times 2. If I went too fast for you, rewind and look at it again, or just pause and look at this. Now, what did I do next to find the least common multiple? Oh, I stacked them like this, where the ones that were common were stacked on top of each other. Okay, I can do that. I have, let's do it over here. I have a 5 times 5. And then on this one, gosh, there aren't any 2's, but I can do 5 times 2 times 2 times 2. Okay, that's what I did. Then I just wrote down each of the numbers at the bottom of the column without duplicating these. I didn't put 4 here and 6 or 9 here. I just wrote the numbers that they represented. So down here, I'm going to write a 5 and a 5 and a 2 and a 2 and a 2. That effectively eliminates one of these 5's so that I'm finding the least common multiple. Some of you guys did 40 times 25, and you got like 400 minutes. Or 400 minutes, I believe. Or 1,000 minutes or something like that. But we don't want 1,000 minutes. Yeah, you got 1,000 minutes. You did 40 times 25 and got 1,000 minutes. That's not the least common factor. That's not the next time they'll meet. That's when they'll meet like 4 times down the road. So if we eliminate this 5, that'll give us the least common factor. 5 times 5 is 25. 25 times 2 is 50. 50 times 2 is 100. And 100 times 2 is 200. 200 minutes. Huge mistake a lot of you guys did. You got to an answer and your brain said, okay, I'm done with this problem. What you didn't do is go back and think about what this represents. This does not represent 2 o'clock. A lot of you wrote down 2 o'clock. No, that represents 200 minutes. From 6 in the morning, that's the next time it'll ring, 200 minutes later. Well, what's 200 minutes after 6 a.m.? Oh, well, let's see. 180 minutes is 3 hours, and 20 more is 20 minutes. So it's actually 3 hours and 20 minutes later. A lot of you got to there and you wrote 3:20. It'll ring at 3:20. It won't ring at 3:20. It'll ring 3 hours and 20 minutes after 6 o'clock, which happens to be 6 a.m. plus 3 hours and 20 minutes equals 9:20. And that is when those bells will ring together again. One of the problems I see occurring is that you throw answers out there that make sense if you read the problem incorrectly, if you don't read all of the words. For example, if I read this whole thing, but I don't read together, I'll write down, well, the next ring is 6:25 and 6:40. And that's what one person wrote, 6:25 and 6:40. That together is a valuable word. If you cover up next, it says, when will the bells ring together? And a lot of you put down 1,000 minutes later. You put other times that they'll ring together. No, we want the very next time they ring together. You have to be careful as you read instructions and pay close attention to what they mean, where you're headed, okay, so that you don't stop here or stop here, but you go all the way to the end of what they want, what's wanted, okay? We don't want your space shuttle to blow up.